Welcome to another presentation about the Carolina Bays, but this time they are in Mars. Previous presentations have discussed the Glacier ice impact hypothesis published in 2017 that proposes that the Carolina Bays were created from the secondary impacts of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet. The oblique impacts of glacier ice chunks created inclined conical cavities that produce shallow elliptical basins after viscous relaxation. In January 2019, NASA published an image of a fresh impact on Mars that formed between July and September of 2018. The high-resolution camera of the Mars Reconnaissance Orbiter photographed an impact site with long ejecta rays. A meteorite crashed through the ice at the planet's southern ice cap and created a two-tone blast pattern. The impactor penetrated the layer of ice that was on the surface, and the ice was launched a great distance to form the outer light pattern. The dark inner pattern was formed from soil that was excavated from the deeper portion of the impact crater. Some of the ice chunks ejected created secondary impact basins similar to the Carolina Bays. The book on impact cratering by Professor J. Meloche describes the effect of Mars' atmosphere on impact crater ejecta. Atmospheric drag winnows fine ejecta from the expanding curtain. The resulting turbulent dust cloud over the crater falls back, producing density currents whose deposit might explain some features of Martian fluid ice ejecta blankets, according to the hypothesis of Schultz and Gault. Larger ejecta fragments are not deflected and produce secondary craters. Winds driven by the expanding ejecta curtain may modify the deposition of ejecta. From this book, we can see that in 1979, the idea of secondary cratering on Mars was already well established, but it is nice to see physical confirmation from the Mars orbiter. This image shows two areas where the secondary impact craters made by the ejected ice can be seen clearly. After the ice projectiles melt, only the radially oriented cavities remain. I would like to thank Chris Cottrell from the Dabbler's Den for bringing these Martian secondary impacts to my attention. He sent me a picture of the impact area with some arrows showing the distribution of ejecta. Chris had a very successful presentation about the Carolina Bays at the Cosmic Summit that was held in Asheville, North Carolina on June 17, 2023. Mars has a thin atmosphere, so its surface is frequently bombarded by meteorites. A crater was formed on December 24, 2021, when a meteorite struck the ground in a region of Mars called Amazonis Planicia. Boulder-sized blocks of water ice can be seen around the rim of this large impact crater, as viewed by the high-resolution imaging science experiment camera aboard NASA's Mars Reconnaissance Orbiter. The crater has a diameter of about 150 meters, or 490 feet. This is a higher-resolution image of the same impact. No secondary impact craters made by the ice are evident on this rough terrain. The radially aligned secondary impact basins in Mars provide additional evidence of the physical mechanisms that can explain the origin of the Carolina Bays and the Nebraska rainwater basins. The elliptical geometry of the Carolina Bays can be demonstrated by fitting them with ellipses using the least squares method. Since ellipses are conic sections, this implies that these geological features must have originated as inclined conical cavities or penetration funnels. Well-preserved Nebraska rainwater basins can also be shown to have mathematically elliptical geometry. The major axes of the Nebraska rainwater basins and Carolina Bays converge at several locations by the Great Lakes. These convergence points are the probable locations of extraterrestrial impacts, perhaps from a fragmented comet at the time when the Laurentide ice sheet covered North America. If a meteorite impact on an ice sheet in Mars can eject ice chunks that create secondary impact craters, it is equally plausible that this could also happen on the Earth. With this discovery, the case for the impact origin of the Carolina Bays and the Nebraska rainwater basins seems to be gaining strength. Thank you for joining me in the investigation of the Carolina Bays and the Younger Dryas Cataclysm. There's a link to the LiDAR visualization tool in the description of the video. My book about the Carolina Bays is available at Amazon. Please subscribe to my YouTube channel to be notified of future videos about the Carolina Bays and other scientific topics.